So we're now on day 3 of transformations, and now we also have vertex form. Remember vertex form, y equals a times the quantity x minus h quantity squared plus k. Remember, a is a stretch or a shrink. If it's a positive or a negative, positive is going to open up, a negative is going to open down. H is going to be our, so we started on these yesterday, and we talked about the parts of a parabola too. So we're going to go through and list all the things that apply for that parabola. And a lot of times it's easier to just go left to right. So we know that it's going to open down because it's negative. We know that it has a stretch of 3. We know that it has some shifts. And when we do the shifts, we're also going to write the vertex because they're related. Okay? So it shifts. It doesn't shift at all horizontally because there's no parentheses. So we know that this is going to be a 0 for the vertex. But it does shift down 1. So that's a -1 for the vertex. Now, since it opens down, okay, so think about it. It opens down. And if it opens down, is that a max or a min? That's a maximum. Is this going to be wide or narrow? Well, with that stretch of 3, this is going to be narrow. Our axis of symmetry, I mean, we're just hitting everything. Our axis of symmetry, remember, is going to go through 0. It's going to always be x equals whatever x is. So our axis of symmetry is going to be x equals 0. And that's going to be really helpful too, because then we can do those reflection points. Okay, so let's start off with what we've been doing in the past is we're just going to plot the parent function, 0, 0, 1, 1. Now, we can actually use an axis of symmetry right here. And we're going to draw in the axis of symmetry. I'm going to try to do it really wide so you can't miss it. Okay. Hopefully this won't interfere. So this is our axis of symmetry. See how it just goes right through there? So because that is our axis of symmetry, we know that if I go 1 this direction, I can also go 1 this direction. I know my other point is 2, 4. 1, 2, 3, 4. And now, because I can use that axis of symmetry, I don't have to memorize 3 points. Once I have these in, I just know that this is my reflection. So if I go 2 here, 1, 2, 1, 2, then I'm going to go 1, 2 over here. So there's my reflection point. So there's my parent function. Now we know that it opens down, so we're going to have to flip this puppy over. So we're going to go 0, 0 stays. I'm going to flip it over, so if I'm up 1 here, I'm going to be down 1 there. Up 1, down 1. And also that axis of symmetry. So I'm up 4, so I'm going to be down 4. 1, 2, 3, 4. And then by using my axis of symmetry, I know I'm going to go to the other side. So I've opened down, stretch of 3 I haven't done yet, and I haven't done the shift. Now I'm finding, especially when it gets to a fraction for a shrink, it's going to be easier if we do the stretch first. So I'm going to go ahead and do the stretch right now. My y-axis right now, so if we want to go with that table again, and then we'll do a shift. So stretch of 3. If my y value is -1, I'm going to multiply it by 3. I'm going to get a -3. My y value is a -12, so that's 1, 2, 3, 4. Sorry. So -4 times 3 is -12. I was doing it before I did it. So now, if I draw in my stretch, it's going to be -3. And also I can just look here. It's 1. I'm going to multiply it by 3. It's -4. I'm going to multiply it by 3. So 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 11, yeah. And I'm going to just do my axis of symmetry and do my reflection point. Okay? Now we have done our opens down stretch, and it also kind of makes sense to do that stretch because you're just working from left to right. It shifts down 1, so everything goes down 1. Okay? So here we go. We're going to go down 1, 1, 1, 1, and 1. And we already said it was going to be narrow. Okay? Good. Okay, now on this next one I changed a little bit. So for number 8, I'm going to make it 1/2, just because we haven't practiced that yet. Okay, so let's go through everything that we know. We know that it's positive, so it opens up. We know that it has a shrink. Because it is a fraction, it's a shrink of 1/2. If it opens up, think about that, that's going to be a minimum. It also tells us that it is going to have a shift, and we're going to write the vertex at the same time because those are related. We can just look at it and see what our vertex is, and on the next ones I'll have a start there. But the shifts, it's a negative, it's going to go to the left 3. So that means I have a negative 3. It's going to go down 4. So that's a negative 4. Okay? What did we forget? Is this going to be wide or narrow? This is a shrink, so it's going to be wide. Our axis of symmetry, x equals negative 4. Because I use whatever my x-coordinate is, so x equals negative 4. Okay, negative 3, gosh. I was pointing to it and saying the wrong number. Negative 3. Okay? So, it's going to open up, shrink of 1/2. I think we've got everything. So, we start with our parent function. 1, 2, 3, 4. I still am counting it off, and I could be using that reflection point. What's my axis of symmetry? Okay, so there's my axis of symmetry. Now it's going to shift. I don't want that in, because I want my axis of symmetry off my vertex, not off my vertex of my parent function. Okay, stop that. I want it off negative 3. So, here we go, though. First, we're going to do a shrink of 1/2. So if I do a shrink, my y values right now are 1 and 4. So if I'm going to take it times 1/2, I'm going to come up with 1/2 and 2. So if I look at that, here are my shrinks. Okay? Then I can either move to the vertex and move everything off and then just kind of go off that, or I can count left 3 down 4. But we know our vertex is going to be at negative 3. So I'm just going to go ahead and plot that. So at negative 3, 1, 2, 3, 1, 2, 3, 4. There's my vertex. Now I can draw in a line of symmetry. If I want to then just move 2 points and then do my reflection point. Okay? So I'm just going to move this one over, and what we do when it's 1/2, you just have to stay between the lines. So we're going to go over 1, 2, 3, down 1, 2, 3, 4. And notice I'm just staying between the lines. Don't overthink it. Now I'm going to do a reflection point. Now I'm going to take this and go 1, 2, 3, down 1, 2, 3, 4. Okay? And then it's reflection point, so I go 2 here, I go 2 over there. There is my function. Okay? Good. Let's look at that next page. And at the same time, I'm going to have us look at the assignment. Your assignment's going to be on page 27. And notice it asks for a max and a min, axis of symmetry, vertex. Then it asks what your transformations are. And then it's going to also talk about domain and range. So we'll do one of these too. Okay, so let's do a few more of these just to make sure we're getting it. I would love it, if you would turn off your video, pause the video and write all this stuff down. So I'm going to ask you those questions. Is it opening up or down? So you're going to tell me if it opens up or down. Okay, so I'm just going to put them, you're going to circle them. Is it a max or a min? Wait, I'm not going to do it like that. Okay, so write down if it's an up or down, max or min. I'll wait. Tell me if it's a stretch or a shrink, and if so, how much. Tell me what the shifts are in the vertex. Okay, I'll say those again. Does it open up or down? Is it a max or a min? Does it have a stretch? And if so, what is it? What are its shifts? What's the vertex? And what's the axis of symmetry? Okay, so here we go. Does it open up or down? It opens up, because A is positive. If it opens up, that means that I'm going to have a minimum. And you'll see me do this because it's really helpful for me to go, oh, it's got to be a minimum. I'm going to draw which way it goes. Okay, now I just go left to right. There's going to be a stretch because it's a number that's greater than 1 of 2. As far as my shifts, I know that it shifts Oh, we're going to do the vertex at the same time. It shifts right 1, so that's going to be a positive 1, and then it doesn't shift horizontally at all. Okay? I can then tell my axis of symmetry is right there, so my axis is going to be x equals whatever x is, and here that is 1. Okay? So, here we go. Let's plot our parent function. And you might be getting to the point, some of you are going, I'm not going to do that parent function. I'm going to go right to using the vertex. And you're welcome to do that. This is just kind of a pattern to go off of. So, I know my vertex is going to be 1, 0. I can put that in right now. I can put in my axis of symmetry. I know everything is going to go off that. Now, I'm going to do my stretch next. Because I found with fractions, if you don't do it right at the beginning, I was getting wrong answers. And I've done this lesson many times this week. So my y values are 1 and 4. It's a stretch of 2. Okay, and you can also just kind of look at it. If I have a 1, it's going to be a stretch of 2. Therefore, it's going to go up 2. Okay, and I'm doing them off of this. And that's maybe a little confusing because I'm going to shift them all in just a bit. But I'm doing my stretch right now. Those are the x's. And then I'm going to do a shift. Okay, so now it was 4, so it's going to become 8. 4, 5, 6, 7, 8. 5, 6, 7, 8. Now I'm going to shift them all 1 to the right. So this becomes here, and here, and here, and here. And we've got everything. Oh, didn't hit the vertex. These get easier as we go. Should we do another fraction one? No. We're okay. Let's do this one next, okay? Does it open up or down? Write it down. Is there a stretch or a shrink? Write it down. What are my shifts? If I know my shifts, I can write my vertex. I'm going to give you a couple seconds to do that. Hey, and write down the axis of symmetry too. Okay, ready? So it's negative, so it opens down. It doesn't have any stretch or shrink. There is no, it's a 1, so it doesn't change it at all. My shifts and my vertex I'm going to do at the same time. I can see right now my vertex is going to be negative 3 because I have a left shift of 3 and it doesn't go up any place, so it's going to be a 0. If this is my vertex, my axis of symmetry is going to be x equals negative 3. Okay? And I'm going to wait on that. Now this opens down, so to tell you the truth, if it opens down, instead of putting in the parent function, I might go right to putting in upside down. Putting in the parent function, and if you want to, you can always turn it upside down and go, hey, my parent function, if it has to open down, I'm just going to shift it down. So here's 0, 0, 1, 1, negative 1, 1, 2, 4. Okay, now I'm going to turn my paper back around, but if I ever have a flip upside down, I can actually start the parent function. I can actually take care of that down to begin with. It opens down. Okay, now what else do I have? I don't have a stretch, so I just have a shift left 3. So I'm just going to take everything and go left 3, and also look at where that vertex is. 1, 2, 3. I'm going to shift this one 1, 2, 3. But then I'm going to use my axis of symmetry. Here's my axis of symmetry, right? So if I have 1 there, I'm going to have 1 there. I'm going to move 1. I'm going to just move 3 of my points and then just shift them. So now I shift 1, 2, 3, and I'm going to do my axis of symmetry. 2 away here, so 2 away there. There's my graph. Okay. Let's do another big one like this. 2x minus 1. So we have to pretty much do everything. Are you ready? Okay, so right now, here are your questions. Does it open up or down? Write that down, which way it opens. Do I have a stretch or a shrink? And if so, how much? What are my shifts? What is my vertex? Go ahead and throw in the axis of symmetry too. So I'll say them again. Does it open up or down? Is there a stretch or a shrink? If so, how much? What are my shifts? What is my vertex? What's my axis of symmetry? Oh, we've been forgetting to say if it's a max or a min. That's okay, you'll do fine. We'll do it this time. Okay, you ready? Okay, so you're basically going from left to right. Have you noticed that? Is it negative? Nope, so therefore it opens up. It's going to be a stretch of 2. It's going to shift right 1. So it's right 1, that means that my vertex is positive 1. And it's going to go down 4. So it's a negative 4. Since I have my vertex, I have my axis of symmetry. X equals whatever x is. Hey, is this a max or a min? It opens up, so it's going to be a min. Okay? So here we go. If you want to, again, pause yours. See if you can get it all by yourself. So it's going to open up. Here's my parent function. Okay? I have a stretch of 2. So I can draw those in. Stretching at 2, that means that this one's going to go up here, and up here, and 4, 5, 6, 7, 8. Now I can shift it all. Here's my vertex of 1, negative 4. So 1, negative 4. Everything's going to be based off of that. So here's my axis of symmetry. I'm going to take the right-hand side and I'm going to do those shifts, and then I'm going to do the reflection point. So here I'm going to go right 1, down 4, and then I'm going to do reflection, so over 1 here, over 1 there. Now I'm going to do this one, right 1, down 4, and I'm going to do the reflection point there. There's my graph. Okay, let's go back to this one and make it into a fraction. We're going to make this 1/3 because that's going to be pleasant. Hey, but 1/3 on a graph looks pretty much like 1/2, so no big deal. Okay, are you ready? Okay, does it open up or down? Is it a stretch or a shrink? Remember, we changed this to 1/3. Is it a max or a min? What are my shifts? What's the vertex? What's the axis of symmetry? Ready? Okay, it opens up. It's going to be a shrink of 1/3. There is a shift of right 2. So my vertex is going to be 2, 0. Therefore, my axis of symmetry is going to be x equals 2. It opens up, so that means this is a minimum. Okay, how'd you do? Hopefully you got all of those right. Okay, again, pause yours if you want to. Try it all on your own, although we haven't done a 1/3. Okay, so here we go. It opens up, parent function, parent function. Okay, now we're going to go through and do the stretch. So y values are 1 and 4, multiplying by 1/3, that's 1/3, and that's 4/3, which is 1 and 1/3. So nice numbers. Yeah, this is awesome. Okay, so we're going to go 1/3. Now my 1/3 is going to be pretty much like my 1/2, because it's just going to go right in between. Okay, see those right there? I'm just going to say that's 1/3. And then 4/3, well, that is 1 and 1/3. Oh my gosh, this is going to be wide. Okay, do you see that? And here's your vertex. So we've opened up, shrink of 1/3, not 1/2, sorry. Now I'm going to set everything right 2. I'm going to start with the vertex, 1, 2. And again, drawing you that axis of symmetry so I can just do my reflection points. Okay? So now I'm going to shift everything. I've done that one, shift this one, 1, 2. So it's going to be right there. Hey, that one shows up to be the same. Okay, right there. Then I'm going to shift this, 1, 2. And therefore, I'm going to go to the other direction. So this is my very wide parabola. Okay, good. Okay, so for homework, you're going to check in Schoology, you're going to check with your teacher, but it's going to be on page 27. It's a Vertex Form, and there is a front and a back. I think we tried all of them. Oh, domain and range. Okay, let's go back and talk domain and range on all these. Remember that domain, those are your x values. What can they be? And pretty much what we have to talk about is there a restriction? And range. Okay? The domain, remember the x values, so range is your y values. Whoops, can't see that. Domain is your x values. So is there any restriction on what my x value can be? Is there anything that it can't be? No. So, interval notation, here we go. Negative infinity to infinity. Why are we doing this right now? Because you're going to see domain and range on your EOC, so it's good that we're doing this. Now your range, that's where we're going to be limited. Your y values, because look at my y values right here. They go from here on up, right? See how they go from here on up? So my range goes from 0. Now is 0 part of the solution? It sure is. So that's going to be a square bracket. And what's it going to? Positive infinity. Let's go back. Well, let's look at this one. Any restriction on my domain? Nope. So it's all real numbers. Negative infinity to infinity. Range. What are my y values? Well, they're starting way down here. And notice that it's going to be your vertex. Your vertex. So it's going to start at the y value of your vertex and go on forever and ever. Okay? Let's look at this one. Woohoo! Domain here. Draw a little line. Okay, so we're going to have domain and range. Domain, again, any restriction. Hello, you probably figured that out by now. There's not going to be, because it's opening up and down. Okay, so your x values can go this way, but it's the range that makes a difference. Look right here. It's from here on down. So what is that? Again, look at your vertex. See that vertex right up there? That's going to tell you that it's going to start at 0, and it's going to go to what? What's it go towards? Negative infinity, exactly. Okay? This one, not anything too exciting. Domain, guess what? Negative infinity to infinity. Yep, monotone voice because it's really just no big deal. But what's your range? Yep, look again. That vertex for your range, 0, 2, and what is it doing? It's going up, so it's going to be a positive infinity. Okay? So on your homework, you're going to get to do that. You're going to circle max or min, write in your axis of symmetry. Now, they do this in a different order. I think it's kind of a weird order. Yeah, max and min. How does it open, up or down? So that's kind of what max and min is talking about. If I were doing this, I'd go here, here, here. Okay? I would do it in reverse order. And they say translate up and down. I'm going to state how much. So if it translates down 3, I'm going to put circle down and put a 3 over here. Then you're going to graph it over here just like we've been doing it. Okay? So talk with your teachers. Check on Schoology. You're going to find out what your assignment is. Okay? If you have any questions, you know where to find us.